Hey, what's going on, guys? Let's do this problem right here. We have a question that's asking 12 microcoulomb charge is placed at the origin. A second minus 8 microcoulomb charge is placed 1 meter to the right of the first. At what location will the electric field equal to 0? So let's see how we can figure this one out. So first of all, let's draw the diagram. So here we go. So this is our y-axis. Since we don't have anything in y-axis, we can keep it short. And let's draw the x-axis. Okay, and we have this 12 microcoulomb in the origin. That's a positive sign in front of it, so this is going to be positive right here. Positive, we know that electric field is going to be emitting outside for a positive charge. So it's going to be in this direction. Then they are saying a second negative 8 microcoulomb is charged. Microcoulomb charge is placed 1 meter to the right. So we have a negative charge right here. Its distance is 1 meter, and also they have given that distance is 1 meter, and if it's negative, the electric field will emitting inside. So it's going to be this way, and let's see what happens. And now the question is asking, at what location will the electric field equal to 0? So here we have three types of locations. One is, so let's say this is one first, and in between them second, and away from them it's third. And what happened, like if I pick up a location right here, let's say I pick up a location right here, what's gonna happen? Okay, if I pick up a location right here, this plus sign, this is going to be going this direction, right? So E1, let's call this one E1, and here it's going to be this direction. Since it's going away, this is going to be this direction, this E1 right here, E1, and here also same direction, E1 is going to be in this direction. What will this negative sign will do? If you see, it's going toward the negative sign, right? So here the E2 is going to be in this direction. Here also same thing. And in this, if I pick up a location right here, it's going to be going this direction, right? Going toward the negative sign. So this is E2. And let's see what we can find out. So since they are asking for the electric field that is equal to 0, if you notice, this is going to be a positive electric field because it's a positive sign, right? So this one is positive and this one is negative, right? So in order to cancel each other, it has to be like, if it's in the same direction, it won't cancel each other. So this is not gonna work, this location not gonna work, because this doesn't cancel each other, and we have to bring it to 0, right? And also here, this is the biggest electric charge. This is 12 microcoulomb, right? 12 microcoulomb is our Q1. And then here we have Q2. Q2, that is negative 8 microcoulomb. Negative 8 microcoulomb. And this location is near to the biggest charge right here. So this will be never be equal, like if it's near to the biggest electric charge. So this is also not possible. This location, both are opposite side, so it will cancel each other, and we can find a value for, like we can find a location that make it equal to 0. So let's figure it out first. So first of all, let's put the equations for these things. So let's say this is our location, random locations. Let's call this distance from here to here, it's x, and we know this is from here to here, it was 1 meter. Therefore this is from here to here. If this one is x, this is going to be x minus 1, right? So we have all these things. So let's pick up one of these equations. We have to find electric field, so we can use this one right here. Let's call this one E1. I'm doing for the positive charge, KQ over R square. So here K is going to be 9 times 10 to the power of 9 Newton meter square per coulomb square times Q, that is 12 microcoulomb. So 12 times 10 to the power of minus 6 coulomb divided by the R square. So that is the distance from here to the point, the random point we chose, that's x. So let's put x square. So this is one of our equation, and E2, this is gonna be KQ R square, same equation. Here K is 9 times 10 to the power of 9 Newton meter square per coulomb square. And here I'm going to take the magnitude, so we are taking the magnitude. So let's say E1 magnitude is equal to E2 magnitude. So here we are taking 8 microcoulomb, 8 times 10 to the power of minus 6 coulomb. So I keep this one positive because we are taking the magnitude. But at the end we know this is going to be negative because it's a negative like this charge is negative, right? And then here we have the distance from negative to the random location we chose. It's x minus 1 because this is 1, this is x, so x minus 1 is going to give us this distance. So here this is going to be x minus 1 square. And also we know if we want to get zero electric field, both must be equal, positive and negative, it must be equal, then only we will get, like when we add them together we will get 0, right? So therefore this should be equal, so we can equate these two and find the x value, right? Find the x value, that's the question. At what distance or location will the electric field will be 0? So here E1 is equal to E2. So let's put all the values. 9 times 10 to the power of 9 times 12 times 10 to the power of minus 6 over x square. In the other side we have 9 times 10 to the power of 9 times 8 times 10 to the power of minus 6 over x minus 1 square. So I can cancel these two, and also I can cancel this one right here. Then I have left with this one, 12, 8, x minus 1 square, and this one. Let's cross multiply everything. So 12 times x minus 1 square is equal to 8x. So this one I can expand this one a little bit, and this is x square, right? This is x square. So this is going to be square. I can expand this one. So this, if I expand this one, this is going to be x square minus 2x plus 1. And here we are going to have 8x square. So let's simplify everything. 12x square minus 24x plus 12. Bring this 8 to this side, so it's going to be minus 8x square equal to 0. So here we're going to have 4x square minus 24x plus 12 is equal to 0. If I divide everything by 4, this is going to be x square minus 6x plus 3 equal to 0. Okay, now this we don't have any number to factor it directly. Let's use this equation. X is equal to minus b plus or minus b square minus 4ac divided by 4ac divided by 2a. So here we have minus 6b, so minus 6, that's going to be plus 6. So plus 6 plus or minus 6 square, that's going to be 36, minus 4 times 1 times c, that is 3. 4 times 1 times 3 divided by 2, and if you do that you will get, let's continue this one right here. Okay, so if you calculate this one you will end up with these two answers. X is equal to 6 plus square root of 24 over 2, and also or x is equal to 6 minus square root of 24 over 2, and this one gives you 5.45 meter, and the other one gives you 0.55 meter, and we know this distance is definitely greater than 1 because we already know this both are same direction. Therefore this location is not possible to get a 0 value, right? So therefore this we choose this location that is greater than 1. Therefore this answer doesn't match with this. So we know definitely this is the location where we are going to get this electric field equal to 0, and that's how we do these problems. I hope you guys like this video. See you next time.